Hi, everyone. It's a real pleasure to be here. Thank you for the introduction, Sandy. So, like Sandy said, I'm doing a JD PhD. I completed my JD at Harvard, and now I'm wrapping up my PhD at MIT. And really, the focus of my study is computational law, so kind of leveraging advanced computational techniques to improve our understanding of legal systems and also the way we deploy regulation. And what I'd like to talk to you about today is regulation by design, which is this research theme that's emerged, where what we're trying to do is to embed regulatory objectives into technical systems. And this isn't really a new thing. So if you think back to, say, the invention of the passenger elevator was invented actually in Vermont, close by a man named Elijah Otis. No one wanted to get into the elevator because they were maybe understandably scared they'd fall to their deaths. And so what Elijah did is he went to the New York World Fair in 1853. He stood on his elevator platform, he cut the rope, and nothing happened because there were ratchets installed inside of the elevator that stopped his fall. And this is kind of an example of safety by design, right? Embedding a safety mechanism into a technical system. This is really quite an obvious thing to do, but what we'd like to do is to take it one step further and to say, well, can we embed other types of important policy objectives into technical systems? And the nice thing about AI is it really lends itself to this because fundamentally the way we design AI systems is we define an objective function, and then we kind of iteratively optimize the technology to meet that objective function. And it's really all we have to do is to place the regulatory objectives we care about into this objective function. And there's obvious reasons why we might want to do this. On the one hand, the AI supply chain is fairly complex, fairly fragmented, and what that means is that we have kind of series of steps that are taken from data collection and preparation to taking that data and maybe annotating it, collecting it into different kind of like meta packages, then training foundation or general purpose models, and then finally folks taking those general purpose models and actually deploying them. And what it means is that the final deployers actually have very little influence on what is inside of the models. And so if we want them to comply with regulation, ideally we would have some sort of compliance installed in those models when the kind of final level of developers get access to them. Second is we worry about quashing innovation. We want to make it easy to comply with AI regulation. And so the more we can do to kind of automate and streamline that process, the better for lower resource players. And finally, from a kind of more business perspective, the fines under the various emerging AI regulations are really quite stiff. And so there's kind of an economic incentive to try and make sure that you comply as much as possible, ideally in kind of a technically rigorous fashion. So just by way of example, the EU AI Act foresees fines of up to 7% of global revenue. So this is something to pay attention to. So I'd like to walk you through a couple of examples of how regulation by design might look, some of the technical research questions that we're raising, and then kind of wrap up by what we're actually doing in the real world about this. So the EU AI Act is a risk-based framework, right? So that means that depending on the level of risk posed by your AI system, we have different kinds of compliance obligations. But the problem is that the general purpose AI models, things like ChatGPT, things like Google's Gemini, Claude by Anthropic, they kind of lend themselves to all sorts of things. And so you can use them in very innocuous ways, but you can also use them for quote unquote high-risk applications like education, like employment screening. And so the research question is, can we design AI systems that actually know whether they're engaged in a high-risk application of AI and then either alert the developers to that fact or even better, they just go ahead and comply with the relevant regulations in kind of a flexible way. The second area is data quality. So if you are a high-risk application under the EU AI Act, then you have a responsibility to make sure that your training and evaluation data is first of all correct, free of errors and representative. And if we have machine learning practitioners in the room, they'll kind of look at that and say, well, that's impossible to do when we're training a machine on all of the internet. How do we make sure there are no errors? And so that begs the question, what do we really mean by that? What do the regulators mean by that? And what kind of benchmarks can the technical community come up with to ensure that we have the right kind of data quality in a way that we can measure it ideally? And what can we do about the pipeline that creates all of this AI training data to try to make sure that we comply with the regulation and have high quality data? Another requirement under the AI Act relates to reinforcement learning. And so there the fear is that we have an AI system that's actually unbiased, that's performing the way it should, and we deploy it onto the world, and through the user feedback it gets, it starts kind of veering off course. And so there's a responsibility for deployers of such systems to ensure that no biases develop. This is really quite hard to do, right? How do you monitor a system post-deployment? And again, there's a host of research questions about how do we design benchmarks that we can actually deploy in an iterative fashion so that even after the AI system is out on the market, we can kind of constrain its behavior. Moving away from the EU, in the US we have copyright infringement, which is kind of a hot topic and a hot button issue for AI. And there have been repeated attempts by technologists to say, well, we can just measure the similarity between outputs and inputs and make sure that there's no copyright infringement. It's not quite that simple because the way that we assess copyright infringement includes something called substantial similarity, which is kind of this murky, fuzzy concept that is ultimately going to be assessed by jurors. And so what we're interested in is saying, well, can we get machine learning models to actually learn the way that a juror would assess substantial similarity? So rather than trying to rely on technical mechanisms and metrics, can we learn the kind of human fuzziness and the subjectivity and then use that to try and steer us away from copyright infringement? A final example of regulation by design, there was an interesting case in Canada where a chatbot deployed by Air Canada actually issued a customer a refund that the customer wasn't entitled to. And the court ruled that if the information that is on Air Canada's website is something that Air Canada is responsible for, there's no reason to think that they wouldn't also be responsible for the output of the chatbot. And so regardless of whether or not the chatbot's output was actually in agreement with the kind of policy that Air Canada has, the customers were entitled to a refund. And so what we're exploring is the ability to design kind of custom screening policies. So forget about, regulation imposed by government, but can we as a company, for example, deploying AI systems, define a set of policies that those AI systems accord with and kind of constrain the behavior. And so kind of to wrap up, what are we doing about this? This is all like exciting research. As Sandy kind of signaled, we're working really quite closely with folks in the EU Commission, including the key people who've deployed the EU AI Act. And what we're trying to do is to go through all of the EU AI Act and essentially establish a technical research agenda and then to translate that to the technical research community and say, look, like it's great you're building AI systems, but here's like 100 problems we need to fix if you want these systems to be safe and deployed worldwide. We're going beyond the EU, of course, so we're also working with a host of kind of regulatory agencies to try to understand what are the kind of technical metrics and standards we can define to make it easier to comply with regulations that are forthcoming. So we've met with the World Bank, the CFTC, we've given presentations at the New York City Bar Association, we've written comments to the US Copyright Office. So we're really trying to kind of go broad. Beyond Europe and the US, we're also working with the Singaporean Privacy Agency, where the requirements are actually quite different, and it's interesting to work in that context. On the technical side, we have a couple of research projects that we've launched that aren't directly on point with regulation by design, but kind of capture the spirit. So we've convened an effort we call the Data Provenance Initiative with, at this point, over 65 collaborators, where we're going through tens of thousands of AI training data sets and figuring out where did they actually come from. Because without having that information about the licenses, about the creators, it's really hard to make informed decisions about how to use the data. And so that was covered by the Washington Post. We have an open source tool that anyone can use, and we're significantly expanding that effort. On the more legal side, I said I was a JD, so I'm interested in these things too. We're building tools to help individuals navigating litigation to find the case law that supports their case in a way that prevents hallucination. So we're really quite concerned that you could have a chatbot companion like this give you bogus case law citations, and then you would look quite poor in court. And so we've developed a series of approaches to kind of make sure that whatever recommendations you get are actually real and based on case law. To wrap up, we think this is kind of an interesting new paradigm for regulation. It's not that new, right? I mean, we're taking the regulation that's already out there, we're just kind of translating it into a set of instructions that can be parsed and implemented by technology. And so, to Dr. Nelson's point, maybe this is kind of an interesting approach to regulating AI and to actually enabling policymakers to regulate more effectively. Of course, it's not easy, it's not a panacea. On the one hand, this requires a fairly deep understanding of technology by policymakers, and we're doing our utmost to try and convey that. At the same time, it also requires a step towards standardization, not just within jurisdictions, but across them. We found again and again that the market for AI, the supply chain, it's super fragmented, it's very international. And so without some degree of collaboration and interactivity, it's quite hard to really intervene in effective ways. So I'll leave it there. Like I said, great pleasure to be here and happy to chat after. Thank you.